We'll now look at R combinations. In the previous video, we saw R permutations, which is choosing ordered list of elements, different elements, and R combinations is choosing an unordered subset of R distinct elements. We'll see that this is very closely related to R permutations. And like the examples we did, where suppose you have 9 people and you have to pick 1 chair and 1 secretary, here the order matters. And so this is an example of permutation, whereas if you were to say just want to pick 2 people for some committee, then that's an example of a combination. So combination is a subset, whereas a permutation is a list. There is one notation before we start. And that is for the number of R permutations is denoted P, N, R. And the number of R combinations is denoted, this is a new notation, so it's pronounced N choose R, and it's 2 braces, 2 brackets, and then N and R. N is the larger number, R is the smaller number, and this is number of R combinations. Now the way I'm going to do this video is I'll first tell you what this number is, and then we'll do an example, and then I'll explain where this number comes from. It turns out the total number of R combinations is n factorial over R factorial times n minus R factorial. And recall that the total number of R permutations is n factorial over n minus R factorial. So you can see that these two are related to each other, but to get the R combinations, you have to further divide by R factorial. And the reason for this will become clear in a few moments. So let's do an example. An R combination is just a subset. So this is a question that you already have encountered many times before. That is, what are the all the subsets of a set? But instead of asking all the subsets, we are now going to focus on what are the R subsets of a set, or more specifically, how many R subsets does a set have? So let me write that down in detail. So we're asking how many 3-element subsets does the set ABCD have? Okay, so now I'm looking for a 3 combination. And the total size is 4. And so my answer without any extra work is N choose R, which in our case is 4 choose 3, which is 4 factorial over 3 factorial times 3 minus 1 factorial, which is 4 times 3 times 2 times 1. 3 minus, oh, sorry, that should be 4 minus 3 factorial. And then 4 minus 3 is 1, and 1 factorial is just 1. Okay, and then we get cancellations. And 4 over 1 is just 4. So I get the answer is 4, and there are exactly 4 subsets of that set. And now just for verification, we can list them out, but this is an optional step. So what are they? I want 3-element subsets of ABCD. So I'll get ABC, I'll drop the D, get ABD, ACD, and you can see that these are all of them. Okay, so without having to list these, I could directly say that the answer is 4. So that's combinations. It's just a number, but it's extremely useful. It lets you compute many relevant things very quickly. Let's go to the example above where we had, say you wanted to form a subcommittee of 2 people. From a group of 9. Okay, again, the order does not matter, so it's a combination. R is 2, N is 9. And so without actually listing all the possible subcommittees, I'm just going to tell you that the answer is n choose r, which is 9 choose 2, which is 9 factorial over 2 factorial times 9 minus 7 factorial, 9 minus 2 factorial. And now I can do the whole expansion and expand out all the factorials. But I'll use this trick. Notice that 9 factorial is 9 times 8 times 7 and so on. And 7 factorial is 7 times 6 times and so on. So 7 factorial is in fact a part of 9 factorial. So I can actually cancel these out and I'm left with 9 times 8. So I get 9 times 8 over 2 times 1. I can leave my answer as this. This is totally fine. I can simplify it slightly and I'll leave it like that. So the total number of ways of forming a subset of 2 people out of 9 is 9 times 4, which is 36. And you can imagine that it's going to take a while to list all the 36 possible pairs, subsets, and maybe you will make a mistake. So this is a much more robust and quicker way of finding the number of subsets. In fact, just to do one more quick example, let's do a 3-element subsets. And let's say things in action. So elements of size 3 are this, elements of subsets of size 2 are these, subsets of size 1 are these, and then the empty set is a subset of size 0. Now we can just list them out and we know exactly what they are. But now we can, if we just wanted to count, we could have done a quick calculation like that. So 3 choose 3 is the total subsets of size 3, which is 3 factorial over 3 factorial times 0 factorial. 3 factorial cancels, 0 factorial is 1, so I get 1. That is that one. Then 3 subsets of size 2 is 3 choose 2, which is 3 factorial over 2 factorial times 1 factorial. And now 3 factorial and 2 factorial cancel, and you get 3 over 1, which is 3. And these are these 3. Then 3 choose 1 is 3 factorial. Same thing. And then subsets of size 0 is 3 choose 0, which is 3 factorial, or 0 factorial, 3 factorial, which is 1. And so you can see that in this simple case, n choose k is giving us k element subsets. Now let's do the derivation. I want to show the number of subsets of size k of a set of size n is n factorial over k factorial n minus k factorial. And again, I won't do the entire proof in all the detail because it's a little tedious. But instead, I will give you the sketch of the proof. So the idea is we look at the set of R permutations and the set of R combinations. And we construct a map between these two sets. We construct a function. I'll call this forget. And what does this function do? It takes an R permutation and it forgets the order and just remembers the underlying set. So let me give you a concrete example. Let's say I am looking at the collection of the same set above of 3 elements, A, B, C, and I look at 2 permutations. So how many 2 permutations are there? I have AB, AC. I'm going to write it like this: AB, BA, AC, CA, BC, CA, BC, CB. Okay, so these are the 2 permutations. The order matters. So AB is different from BA. Now let me list the 2 combinations. Here order does not matter, so I'll write them as sets. And now what I'll do is I will map AB, the ordered thing AB, to the unordered thing AB. Similarly, BA will go to the set BA, which is the same as set AB. So that's my map. And I can do this for any n and any r. So this is a well-defined function. I just forget the underlying order. But now if you look at what is happening in this particular example, two elements are mapping to one element. So it's not one-to-one, but it is onto, but you can count how many elements are mapping to one single one. And because that number is fixed, that is 2, the right-hand side is half the left-hand side. So I get the right-hand side by dividing on the left-hand side by 2. Okay, so that's the key insight. And we'll make this. So the idea is we ask how many different R permutations map to the same R combination. In the above a concrete example, the answer is 2. Now, what is the answer in general? Well, let's see. So let me fix an R combination. So let's just say it is 1, 2, 3 up to R. Why not? The exact numbers doesn't matter. You can use A1, A2, AR if you want. Now, how many R combinations go to this one? The answer is any permutation of these is going to map to this. And so anyway I order these things, I will, when I forget the order, I'll recover the same R combination. So the question can be now rephrased as how many ways are there of permuting R elements? And we saw the answer to this in the previous video. It's R factorial. R factorial exactly number of ways of putting an order on R elements. Okay, so these are the number of permutations that map to the same combination. And so the number of R combinations is the number of R permutations divided by R factorial. But we computed the formula in the previous video. And remember, this notation is just n. And the formula we had was n factorial over n minus R factorial. And then this whole thing is divided by R factorial. And so this is, and that's the formula for n choose R. Okay, so the derivation is intricate, but the great news is that once you have derived it, you don't have to go through it every single time. You just need to know that n choose R is n factorial or R factorial minus R factorial, and you will use this very quickly to solve many counting problems.